Hello friends, welcome to the Unite coaching. In this lecture, we are going to talk about the matrices, its basic introduction and properties. And moving on to the other lectures, we'll see some advanced concepts in the matrices. Okay, now before moving on to this lecture, I want you to get familiarized with the Unite coaching. So we have our website that is www.unitecoaching.com. On this website, we have made available the video lectures, the PDF format notes, and the PowerPoint presentations. Okay, we also have our Unite Coaching app, which is available on Play Store, and all these materials are also available on this app. So you can go there, check it out, install the app, and enjoy. Okay, so talking about the syllabus of matrices, we have the basic introduction, the properties of matrices. So these first two topics we are going to cover in this first lecture. So we are going to see the definition and properties of matrices and determinants. And in the upcoming lecture, we are going to talk about the types of matrices, how to find the rank of matrices using the echelon form, reduction to normal form, and PAQ normal form. And we'll see what is the importance of rank of the matrices. Right. After that, we'll see how to find the inverse of matrices using adjoint method. Okay. And then after covering all these lectures, all these topics, we are going to apply these for these two topics, that is system of homogeneous and non-homogeneous equations and linearly dependent and independent vectors. Okay, so let's start the lecture. So starting with the introduction, we have matrix, the definition of matrix. So matrix is defined as arrangement of symbols in array form. So here we are talking about symbols and arrays. So what is arrays? Arrays is basically the row and column form. Can you recall your school days? In the school, we used to form arrays and columns. Can you remember where? Okay, let me explain. In the school times, we used to gather in the school ground for the prayer. There we used to form the rows of students for the prayer, right? So that was what were the arrays, right? So that is the row and column form which we call as arrays. And talking about the symbols, those symbols are whatever we are arranging in array form. So those whatever we are arranging, we call them as symbols, right? So these symbol can be real numbers, complex numbers, expressions, and the school times they can be students. Okay, so matrix is defined as arrangement of symbols in array form, and these symbols can be real numbers, complex numbers, and expressions, etc., etc. Right. So how do we represent them in the mathematics? So talking about the mathematics of the matrix, we have we represent them as this. So we have a matrix A, which we represent with the help of two parentheses or two square brackets, right? And in between them, we mention or we write all the elements of the matrices, right? All the elements of matrix. So all these elements a11, a12, a1n, am2, a22, amn, all these are the elements or symbols of this matrix, right? So these first two are the extended form of the matrix, extended representation of the matrix. We also have one compact representation of a matrix. Compact representation means the representation in which with a single element we represent all the elements of the matrix. So this is what we call as compact form of the representation of the matrix, right? So where do we use this extended form and this compact form? So in the case if we need to if all the elements of the matrix are different, so in that case we need to mention all the elements of the matrix. So in that case we will use this extended form of the matrix. Now if we just need to represent a matrix, that is we want to say A is a matrix, so we can use this compact form. So we don't need to write this extended form and use more space. Instead we just can use this compact form and show to the reader that this is a matrix, right? So how do we come up with this compact form? So talking about this, we have represented the compact form as aij covering in the square brackets, right? So this aij, here I represents the row position and j represent the column position. Okay, so say we have a22, so here we have the value of I as 2, the value of j as 2, meaning that this a22 is present in the second row and the second column, right? And talking about this a1n, where the value of I is 1 and the value of j is n, so this means that this a1n, sorry, a1n is present in the first row and the nth column, right? So this is what aij represents. I represents the row position and j represents the column position. This means we can vary the value of I from 1 till m and value of j from 1 till n. Okay, so we have the value of I can be greater than equal to 1 and less than equal to m, where m represents the number of rows and j is greater than equal to 1 and less than equal to n, which means j can be varied from 1 2 3 till n, and where the n represents the number of columns. So this is how we represent matrix. Okay, we often now talking about another term called the order of matrix. So this is a very special term, that is the order of matrix we assign to the matrix. Okay, so we define the order of matrix as number of rows into number of columns. So we have order is equal to m into n, where m is equal to number of rows and n is equal to number of columns. Okay, so we represent the order as m into n. Remember, we just represent this, we don't calculate this product, right? So if we have two rows and three columns for a matrix, that is a matrix exists there that which have two rows and three columns, so in that case the order of that matrix is gonna be 2 and 2 3, not 6, right? So we don't say that the order of matrix is 6 because we don't calculate the product, right? We just represent this as 2 and 2 3, right? So this is just a representation, we don't calculate the product and we just represent that number of rows into number of columns is equal to order. Remember this. Okay, so we have all this what we call as a matrices, right? So now moving on. So now talking about the determinant. So we have determinant as a number assigned only to the square matrices. So determinant is just a number which we will see how to calculate, and this is assigned only to the square matrices, which means if the matrices are square, then only we will talk about the square matrices. If the matrices are non-square, then we don't talk about the determinants, right? So what is a square matrix? Square matrices are those matrices in which the number of rows and number of columns are equal. That is, if we have a matrix whose order is 2 cross 3, then this will be a non-square matrix. But if we have a matrix whose order is 3 cross 3, then that will be a square matrix, right? Now moving on, how to calculate the determinant and how to represent it. Okay, so we have this 2 cross 2 matrix whose entries are A B C D. A B C D. Okay, so we represent the determinant with the help of two parallel lines, right? Remember, in the case of matrices we represented it with the two parentheses or two square brackets, right? But in case of determinants we represent them with the two parallel lines and the entries in between them, right? And to calculate the determinant, that is the number, we calculate it as follows: AD minus BC. We write the product of these two numbers, AD minus product of these two numbers. Okay, so this is how we calculate the determinant of a 2 cross 2 matrix. Now calculating the determinant of 3 cross 3 matrix is little bit tricky. So let's see, if we have a 3 cross 3 matrix with the entries A1, A2, A3, B1, B2, B3, C1, C2, C3. So in this case we are going to calculate the determinant on the basis of first row. So whatever now I'm going to tell you or teach you, listen carefully. Okay, so determinant can be calculated with the help of any row or any column. Okay, any row or any column, any row or any column. But in this case we are trying to find it with the help of the first row. Okay, so for the first row we have assigned the signs positive, negative, positive, and then if we it would have been a fourth element after that, then that would have been a negative with the negative sign. And all these signs which we are assigning, they are alternating, right? Positive, negative, positive, negative. Here in the column form, positive, negative, positive, negative, right? In this form, here it is starting with the negative sign, so negative, positive, negative, right? So this is how we assign the these signs. And remember, all these signs are hypothetical signs, which means they are the imaginary signs. We don't need to actually write them, and actually they are not present there, right? We just need to imagine them, we just need to remember them in our mind. Okay, so starting with now moving on to the calculating the determinant, we just write the first element with the post and check its sign. So we have the first element with the positive sign, so we write it A1, and positive sign means we don't need to write anything. Okay, so and then we write this determinant. How do we come up with this determinant? So what we have done is we have taken the this element A1, written it here, then we remove them, right? We remove them, and whatever is remaining we take the determinant of that, right? So we have written A1 and then remove the first row and first column, that is the row and column in which this element is present, and then taken the determinant of the remaining elements, right? So whatever is remaining we have taken the determinant of it. So b2, b3, c2, c3 is remaining, so b2, b3, c2, c3, right? Now for the second element we have written it. Okay, now for the second element a2 we have uh, written it here, and it comes with a negative sign, so we have put it a negative sign here, right? So minus a2. Now whatever is remaining, b1, b3, c1, c3, we take determinant of that, right? Now coming to the third element we write third element as a3, and it comes with a positive sign, so plus a3. And we remove the row and column in which it is present, and whatever is remaining b1, b2, c1, c2, we write them as b1, b2, c1, c2 and take the determinant of that. Okay, now calculating the determinant of this is very easy. So looking at this matrix, we can calculate this determinant, this determinant, this determinant. So a1 into b2 c3 minus c2 b3, b2 c3 minus c2 b3 minus a2, b1 c3 minus c1 b3, b1 c3 minus b3 c1, that is B3C1. Okay, now plus A3 into B1C2 minus B2C1, A3 into B1C2 minus B2C1. Okay, so this is how we define a 3 cross 3 matrix determinant. Alright, so this is very easy. Don't get confused. I will show you some tricks to find the determinant of a 2 cross 2 matrix and 3 cross 3 matrix. Don't get confused with this method. If you get it, then it's okay. If you don't get it, don't worry. I'll show you the another method. Okay, so moving on. Okay, so now we have two important terms to talk about, that is the minor and cofactor. So what is minor? Minor is represented by Mij. Okay, so that is it is assigned to an element of a matrix. That is, if we have Mij, it means we are talking about the minor of element Ij. That is the element present is ith row and jth column. Okay, so how do we find it? So we find it by taking the determinant of whatever elements are remaining by removing the ith row and jth column. So suppose for a 3 cross 3 matrix, we want to calculate this M21. So how do we find the M21? So first look what is this element M21. So this M21 so this element 21 is this element B1, that is the element present in this second row and this first column, right? So this second row and first column means this element B1. So now we want to find the minor for this element. Then we need to do what? We need to remove this second row and first column. That is, we need to remove this second row and first column. Then whatever is remaining means a2, a3, c2, c3 is remaining, so we need to take the determinant of that, a2, a3, c2, c3, and we take the determinant of that. So this is what we call M21 is. So very easy, right? Now moving to cofactor. So how do we calculate the cofactor of a given element, that is Cij? Cij means the cofactor of the element ij, the element present in ith row and jth column, right? So this is calculated by this formula. By this, okay. So to calculate, so what is this formula? This formula is Cij is equal to minus 1 to the power I plus j, that is the sum of the row number and the column number into Mij. So to find the cofactor of a given element, we first need to find the minor of that element, then multiply it with the minus 1 to the power ij. Okay, so suppose we want to find the cofactor for the same element, that is the M21, right? So how do we find it for the C2? How do we find the C21? So we find C21 as C21. Don't worry about the writing, we will provide you the notes. Okay, so C21 is equal to what? Minus 1 to the power minus 1 to the power uh, this this first 2 plus 1, right? So we will be writing here 2 plus 1 into M21, right? And this is this minus 1 to the power 2 plus 1 will be minus 1 to the power 3, and minus 1 to the power 3 will be equal to what? Minus 1 into M21. Okay, so this is how we calculate the cofactor of given element, right? Okay, so now where do we use this minor and cofactor, right? So we use this minor and cofactor in calculating the determinant. So a determinant of a matrix is equal to a11 c11 plus a22 a12 c12 plus so on till we get the last element, that is a1n and c1n. So what does this represent is, that is, we have taken the first row. First we have taken this first row, and then we take the first element a11, multiply it with its cofactor c11, then we add, then we plus a12, that is the element a2 here, a12, then multiply it with its cofactor c12, then plus so on till we get a1n c1n. Alright, so whatever we have seen previously, that is we assign some positive negative sign with these elements, that is plus minus plus minus plus, okay, plus minus, okay. So all these these positive and negative signs, that hypothetical positive and negative signs comes because of this cofactor term, that is because of this minus term, okay. So because of this, what we have got, that previous method of calculating the determinant, okay. So now we will see some tricks and shortcuts to find the determinant, okay.